The third candidate is Jean Lagacé, PhD in mathematics. The title of the project is Spectral Asymptotics and the Geometry of Numbers. 3, 2, 1, chrono.
Hi. So, as a kid, whenever I would go in the kitchen or in the bathroom, I'd look at the tiles on the floor and wonder, what can we say about all those pretty patterns? How can I continue them on under the bath? What can we say about them? If you had told me 20 years ago that I would do this as a job, I'd have said, impossible, this is no job. Well, here we are. One of the questions we can ask about tiles in a bathroom would be, how many of them do we need? It's an important question if you need to tile a bathroom. Well, any tiler would tell you that it takes you about the area of the bathroom, and you divide by the area of every one of those tiles, and it will give you the number of those that you need. However, you want to make sure that you have enough of them, and for this, you have to count the number of those tiles that would be around the perimeter, and that's how many more you need. The reason for this is that these tiles don't fit perfectly into the wider shape of your bathroom. Now, this is no problem when you are in the situation of the bottom left corner, where the perimeter is much smaller than the area, so the first estimation is pretty good. Now, when you're in the second situation of the upper right corner, now the perimeter and the area are comparable, so is our estimation still good? Now, my field, asymptotic analysis, could also be called estimation science, and as such, we have all the right tools to answer these kinds of questions. Now, you can remark that whenever you use a tile around the edge of your bathroom, you might cut it because it will not be full, and you could use the other part around the rest, around some other part in the edge, and that would lead to an overestimation of the error, so maybe you need to buy less. One domain that knows how to deal with these cancellations is in the physics of waves and vibrations, where if you take many waves, add them together, there might be some constructive or destructive interference. One of the main theorems in harmonic analysis tells us that counting those tiles is actually the same thing as calculating the amplitude of one wave that would have its frequencies on the corners of those tiles. In my research, I have showed that this is indeed the case. We have destructive interference, and even in the top right corner case, we still need to estimate with the area, not the perimeter. Now, you'll tell me, come on, my PhD in counting tiles in a bathroom? That's not serious. Indeed, you'd be right. It's the beauty of mathematics. The same model can be used for many different problems, and in this case, the mathematics I've studied can also be used to model, for example, the energy levels in a crystal, or whiskey sloshing around in a glass. This means that for everybody from the physicist to the tiler to the whiskey aficionado, the same mathematics explains parts of their lives.